Hi, everyone. So today we're going to be talking about free volume theory. And so what is free volume? It's basically the empty space between molecules or polymer chains in this case. So there's a case where the free volume is often changing, and this is in liquid polymers or elastomers, or when there's a fixed volume in glassy polymers where they're more rigid. And so the amount of free volume changes between these two cases. So for liquid and elastomers, the molecules move and change conformations easily, so the free volume is high. And for glassy polymers, the motion is limited by steric hindrance, and the free volume is pretty low. And so, of course, we want to discuss how free volume relates to temperature. So we're going to make a model based on occupied versus unoccupied volume. And that is going to be the sum, the total volume is going to be the sum of these two. So it's the free volume, which is the unoccupied volume, plus the occupied volume. And so we're going to graph this over time, volume versus, over temperature, volume over temperature, and pay attention to when the glass transition temperature happens. So for the total volume curve, it first increases linearly and then has a cusp and then increases linearly more. And there's two different regions. There's the glassy and, of course, the rubbery regions of the temperature that we're going to split this into. And so how do we define the total volume? Of course, as we previously mentioned, it's the free volume and the occupied volume. So the occupied volume is actually just this linear increase at first. And that's because as you increase the thermal energy, the bond lengths are going to stretch, and you're just going to see a very basic linear increase on that volume. The free volume, however, gets a little bit more complicated. So in the rubbery region, it's going to have kind of that amount of free volume that you expect in the glassy region. That's just kind of there and fixed and rigid. But then you have an additional increase due to chain motion. And so that's what that kind of sharp increase leads to. And so in a second here, we're going to look at an equation on how to define free volume, but still looking at this graph, it's important to understand that VF star is kind of that initial free volume that you'd expect from the glassy region, that same trend that continues, and then your increased region there. Below that, you have volume from the molecules, which is the occupied volume, and this will fit into our equation pretty nicely. Okay. So the free volume equation that we can write out here is the sum of that VF star plus the kind of slope increase there. We can almost write it as in y equals mx plus b, just like a linear trend, where you have the t minus tg, or the delta x, and this change in slope. So the v over t, that is just your slope from chain motion. And the v naught over t is the bond stretch volume that we kind of discussed earlier. Generally, the bond stretch volume is way smaller than this chain motion volume or change in volume. So we can kind of count that V naught over T as negligible. And so in our final kind of simplified free volume equation, it's going to be the sum of that VF star plus the change in X times your chain motion change in volume. And so if we just plug it into the equation we had before, the unoccupied and the occupied volume, your total volume is going to be VF star plus that increase from the chain motion plus the volume from the molecules. So yeah. Yeah, and we can think of VF star as just the initial free volume. Again, the chain motion and the occupied volume. And so it's important to talk about that this is the case for the rubbery region, because we'll see a different trend in the glassy region where it doesn't have that increase. So yeah, in the glassy region, we're going to see kind of the same equation being used. It still applies. It's just it's the total volume equation, but that there's no chain motion. And so that change in V over change in T term is going to be negligible. You can cross that out, and you just get the initial free volume plus the volume from the bond stretching. And that's going to be your glassy total volume equation. Cool. Thank you for listening, and have a good one.